Let's look deeper into the concept of a popular storage location and frequent visits of storage locations. So which SKU generates the most frequent visits per storage location? We can calculate the average number of visits per storage locations as the number of shipments for this SKU over the maximum number of units of this SKU in storage. Though if we have an SKU that sells 20 pallets per year, but we receive the orders in quantities of 5, which is the same as the maximum units in storage, then the average number of visits per storage locations is only 4, because we have 20 shipments of these pallets, but they are combined in only, then they order 5 pallets at a time. We only have to visit the storage location 4 times. So consider a second example. We have an SKU that sells 100 pallets per year, and we receive for this SKU an order quantity of 50. Then we have on average only 2 visits to the storage locations, because we have to calculate 100 over 50, which is equal to 2. So it might be not super intuitive in the beginning to define what is a popular SKU and a frequent visited storage location. How should we now arrange our product depending on the popularity of the product and the convenience of the storage location? We have a 3-step algorithm to do this. This algorithm assigns SKUs to storage locations, and the goal is to minimize the labor costs, which are expressed in travel distance. In the first step, we look at all available storage positions, at all positions where we can store a pallet, and we order these positions. And we start with the pallet position that has the smallest distance, the smallest travel distance, and we order them in increasing distance, so from the smallest distance to the greatest distance. In a similar way, we rank all the SKUs, but for the SKUs we start the first place, the topmost SKU is the one that has the most turns in a year, and the last SKU in this ordering is the one with the least turns. And then we just take the first pallet position and assign it to the first SKU in these two lists. We take the second pallet position and assign this as a storage location for the second SKU, and so on and so on. And when we do this, then we can minimize the labor costs. Here's an exercise where you can try to practice this. I will not upload the solution as a video. I will upload a handwriting document, probably in forms of JPEG, to the Moodle course to give you a solution to this exercise. But for now, try to solve it yourself. See, we have 2 tables, 2 lists. In the first one, we have 9 storage locations with an associated distance. And in the second table on the right, we have all the 9 SKUs numbered from A to J. And we have the number of turns for this SKU in a year. And the first question this exercise asks, what is the labor cost of the current assignment? And for this current assignment, we assume that location number 1 stores SKU A. Location number 2 stores SKU number B. And in order to calculate the costs, you have to just multiply the travel distance with the number of turns and sum this up for all the combinations of SKUs and storage locations. For the question number 2, you should now apply this ranking algorithm where you have to rank the available pallet positions from the least distance to the greatest. So you have to reorder this list and you have to reorder this list, and then find a new, then you have the new assignment. And if you performed all the steps correctly, the minimum cost should be 270 units.